if I have something like x squared equals, we'll say 9. I've got two options, to solve this, I take the square root of both sides. The square root is kind of the opposite of squaring. When I take the square root of a variable, though, I've got two possible solutions. I can either have positive square root of 9 or negative square root of 9. So, real quick, what is? Yeah, plus or minus 3, right? And I can check that because if I put in 3 squared, that equals what? 9. And if I put in negative 3 quantity squared, that equals positive 9 also, right? So there's two solutions whenever I take the square root of a variable. Next, I want to go, questions on that part?
Yeah. Can you slow down?
Whenever I multiply square roots, for instance, if I had the square root of a times the square root of b, some number a and b, we can rewrite that as the square root of a times b. Okay? That's the product property. So, for example, if I had something like the square root of 4 times the square root of 9, that would be the same as the square root of, what's 4 times 9? 36, and that is 6, right? And we could check that, because the square root of 4 is 2, times the square root of 9, which is 3, is also 6. So I think it works. Okay? All right, let's look at the quotient property, which is very, very similar. It says if I have something like the square root of a divided by the square root of b, that is the same as the square root of a over b. Okay. Both of these properties work two ways. I can start with what I've got on the left and go to the right. I can start with what I've got on the right and go to the left. So they work both directions. Okay. An example of this might be something like the square root of 6 divided by the square root of 9. That is the same as the square root of 6 over 9. And actually, I probably should have used 4, but that's what it would look like in an example. Is to simplify, I have to factor 80. Okay? So I put 80, and I'm probably going to use most of this screen over here on the right, and then erase. But if I have 80, I'm looking for a number that goes into 80. Give me a number that goes into 80. How about a prime number? 2. I like 2.
Or 1.
What is 80 divided by 2? 40. So that's how I find the next number in the box.
Oh, yeah.
Then I ask myself the same question. What prime number will go into 40?
1.
2. Other than 1, John. Think so. 2. What is 40 divided by 2? 20.
Why can't you use 2?
Give me a prime number that goes into 2. Yeah,
2 and 10.
You're right. Yep. 2 again, right? 20 divided by 2 is 10.
5 and 2. 5.
How about 2? 5. 5. When I get to 1, what's 5 divided by 5?
5 and
1. When I get to 1, I stop. At this point, I circle my pairs. Because I'm taking a square root, I'm looking for pairs of 2's. I've got 2 pairs of 2's. So when I rewrite the square root of 80, I can rewrite this as the square root of 2 squared times 2 squared times what?
5.
5. Okay? I've kind of perfectly factored it out. Now, our product property says I can take this and say, well, this is actually the square root of 2 squared times the square root of 2 squared times the square root of 5. Right? Mm-hmm. And what is the square root of 2 squared?
4.
Square root of 4? 2, right? And what is the square root of 2 squared again? 2 times whatever I've got left, the square root of 5 equals 4 square roots of 5. And that's my final answer. So what is 6 times 21? Let's move up here.
126.
So this is the same as the square root of 126.
Don't trust me, okay?
No, I trust you. All right, so let's take 126 and let's factor it. Prime number that goes into 126? 2. What do you get?
You get 63.
63. Prime number that goes into 63?
9 and 7.
How about 3? 7 would have worked also.
Wait, so there have to be prime numbers on the side?
Yes, yep. Always got to have prime numbers, yep. So, yes, 63 divided by 3 is 21. Prime number that goes into 21?
7.
3 or 7. 21 divided by 3 is 7. Last one, 7. And I'm done at 1, right? Stop at 1. So,
That's pretty easy.
yeah, and now I'm going to circle my pairs. I've got one pair of 3s. So I take that pair of 3s up front. Now I'm not going to write yet. Last time I wrote several steps. I wrote like 4 steps. As we move through these and we get a little bit better at them, I think that I can just rewrite this as equals 3 times the square root of whatever is left on the inside.
7 times 2.
7 times
14.
2. Right? So,
9.
yeah, I can rewrite this as the square root of 4 over the square root of 81. These happen to be perfect squares, conveniently. What is the square root of 4? 2
Over 9.
over 9. 2 ninths.
That's so easy.
And that's it. So that's where that quotient property is really, really helpful.
So you don't have to, yeah.
Okay, if the form of the denominator is something like the square root of b, some number b, then I need to multiply the top and bottom by the square root of b. In other words, the square root of b divided by the square root of b. Okay? So I multiply the top by square root of b and the bottom by square root of b. So in my example, if I wanted to rationalize my example up there, I would multiply 4 over square root 3 by square root 3 over square root 3. Okay. If I had the form of the denominator was something like a minus the square root of b, then I need to multiply the top and bottom by a plus the square root of b divided by a minus the square root of b. That is called the conjugate. Plus. They're both plus. They got to be the same. Yes. So that is called the conjugate of a minus b.
Don't you dare conjugate.
Those are different. All right. If I have the form of the denominator
B.
a plus the square root of b,
You have to go A minus.
yeah, the conjugate of a plus the square root of b is a minus the square root of b divided by a minus the square root of b.
So it's kind of like the reciprocal.
Very similar to the reciprocal, yes.
What's conjugated?
Thing. To rationalize the square root of 5 over the square root of 2, I'm going to have to multiply the top and bottom by the square root of 2. Remember, it's that first form. So square root of 2 divided by the square root of 2. That is an okay move because I'm just multiplying by 1. It's okay. I'm not changing the expression at all. Square root of 2 over square root of 2 is just 1. So on the bottom, I get this. The square root of 5, on top I get this, square root of 5 times square root of 2. And on the bottom, I get the square root of 2, I guess we'll write it like this, the square root of 2 times the square root of 2. Okay. Remember, this means the square root of 10 times the square root of 4, and there's still that square root on the bottom, but not anymore because this is the square root of 10 over 2. Multiply by the conjugate. So, if I have 7 plus square root of 3, to get rid of the square root, I've got to multiply by 7 minus the square root of 3 over 7 minus the square root of 3. So I'm going to multiply by, let's do a different color for this. Okay, so multiply by 7 minus the square root of 3 over 7 minus the square root of 3. So that's the conjugate. Now I'm going to simplify this. On top, I'm just multiplying fractions. So on top, I'm going to have 3 times 7 minus the square root of 3. On the bottom, I think I've got something I've got to FOIL. Purple's kind of hard to see. Sorry. Let's go with white. I think I've got something that I've got to FOIL. In other words, let's rewrite it here. This is 7 plus the square root of 3 times 7 minus the square root of 3. And if I FOIL that bottom thing out, I think this is what I'll have. On top, leave that alone. 7 minus the square root of 3. On the bottom, I do the first term, which is 7 times 7 is 49, right? 7 times 7. Okay, outside term, minus 7 times the square root of 3. Inside term, plus 7 square root of 3. And then that last term, I think, is minus the square root of 3 times the square root of 3. Oh, yeah, sorry. Yep. So this is where I end up after I simplify, and if I go a little bit further, let's distribute the top. Can we distribute the top now? Okay, that's going to be 21 minus 3 times the square root of 3, all divided by 49 minus 3, I think is just 46. And that's it. Yeah, the first thing I would do is subtract 5.
Divide by 3.
So I get 3x squared equals, let's see, 41 minus 5? 36.
Divide by 3.
Divide this thing by 3. So I get x squared
Equals 12.
equals 12.
Square root.
Now, I get down to x squared equals 12. If I want to get rid of a squared term, I do the opposite, which is the square root. Now remember, way back at the beginning, I said when I take the square root of a variable, what do I need to be careful with?
Yep.
I need to have what in front?
Plus or minus.
Plus or minus, right? Because I'm taking the square root of a variable. I'm taking the square root of a variable. When I take the square root of a variable, I need to have plus or minus. That's important. Okay, so if I kind of move up the page here,
How do you put plus and minus in front of it?
I'm going to get x equals plus or minus the square root of 12. Now, the square root of 12, is that in as simple a form as it can possibly be in?
Yeah.
I don't think so. We better check. Let's put 12 up in our little box.
6.
No, very good question. Can I just square root it on the calculator by itself? That will give you an estimate of the square root, but mathematicians are a little bit picky and would like the exact solution. So, in other words, don't just punch this into your calculator. You've got to be able to simplify. So, give me a prime number that will go into 12. 2, 6. Another one. 2, 3, 1. Circle my pairs. I've got one pair of 2s. So, x equals plus or minus. Remember, the 2 goes out in front times the square root of whatever's left over, 3. This thing for x. We're trying to get x by itself. So the first thing that I'm going to do is divide by 3. Divide by 3, divide by 3. Did I pick one that... Why did
Can you distribute backwards between
Oh.
Yeah, so you had to distribute it and FOIL it and everything.
Do you have a test graded
Yes.
from yesterday? Square.
From yesterday? No, that was a quiz. X minus 2 squared equals 40 over 3. And now I've got to deal with that squared term. So how do I deal with the squared term? Right. So square root of both sides. And if I move up here, this is going to be then x minus 2 equals plus or minus the square root of 40 over 3. Okay. Oops, where'd my 3 go? Can you not see my 3? There. 40 over 3. I'm going to add 2 to both sides. X equals plus or minus the square root of 40 over 3 plus 2. Now, we could go through and rationalize it, and we probably should, but in the name of time, I'm not going to. But we know that this is the square root of 40 over the square root of 3. I get rid of that square root in the denominator. Well, other than that, this answer is okay. We just need to take it a little bit further and simplify. But I think I got one more example. So
Would you accept that?
Oh, mine says, well,
All the way through. Okay. So, change this to square root of 40 over square root of 3 plus 2 and rationalize. All right. Can I move on? I got one more. I lied. One more slide.